tell me what happened.
Doctor, we were in the organic chemistry lab and I was doing the lab and I told him not to touch anything and I'll be right back, and I left and I came back and he was lying on the floor and he was holding the cup and he had drank it and I need it for my grade. It's like 30% of my grade. We have to get it out of him. I'm not gonna give it to med school.
Get a hold of yourself. We'll do what we can.
Doctor, he's in critical condition. Here's the report.
Nurse, run an IR.
The mass spec indicated a molecular weight of 186.
Alright, let's see what we have here.
Alright, let's take a look at this. Let's start at the 3,000 mark.
Alright.
So I'm seeing a pretty large peak with a lower wavelength than 3,000, which would indicate sp3, carbon to hydrogen bonds.
Okay.
And I'm not really seeing anything, a major peak above that. So you can probably rule out sp2, carbon to hydrogen bonds.
Yes, I agree. We also see another peak over here about 1730. What could that be?
Maybe a carbonyl derivative. The question is what carbonyl, or how many?
Let's refer to our chart over here.
So for all the carbonyl compounds, these are too low of a wavelength probably to be what we're looking at. So you can rule out conjugated, we can rule out a nitrogen-based.
Okay, so could it be an ester?
Ooh, it could very likely be an ester with such a high wavelength like that.
Huh.
Well, yeah, we'll keep that in mind.
Yes.
That's about all I'm seeing.
Yeah, we can't tell much. So I think we might need to run an HNMR.
Here's the HNMR,
Yes.
doctor. Good luck.
Thank you, nurse.
I think we gotta call it.
It's time.
You don't mean.
Dr. Professor. Dr. Professor, so glad you're here. This is what we have so far. We ran an IR. We have an ester possibly, and we have carbon, sp3, single bond. That's all we could tell from the IR. What about the
looking at
HNMR?
We have 4 peaks, 4 of which are quartet, 2 are multiplets, and the last one is a triplet. So this is the most V-shielded, around 4.
Yeah.
So we're dealing with no aromaticity that we can really see. Aromatics would indicate in a range around 6 or 7.
Right.
This is our molecular formula. If we put an ester in, that's 2 oxygens, that's 1 carbon. Do that times 2, that can give all of our oxygens away. We suck all of our hydrogens, and then we used up 2 carbons. Oh, degrees of saturation.
So we have 9 times 2.
Plus 2 minus the hydrogens, 6 over 2, so 3 degrees of saturation.
3 degrees.
We got the 2 from the 2 carbonyls, if we're assuming we have 2 esters.
Right.
So we still have 1 degree of saturation to work with. 7 carbons, 14 hydrogens. I think our first priority is figuring out what the R is. I think we can do that with the HNMR. We know we have ester, another ester somewhere over here.
Yeah.
So what do we see?
Okay.
6, that's 2 sets of 3.
Right.
We put H3s on the end. How many neighbors would a 6 have with a triplet?
2.
And what are those 2 neighbors next to?
They're next to 3, which is these.
So that's done, that's that.
It's that.
Next to the ester. Now that makes sense with the downfield peak next to the oxygen. All right, and then we gotta move to the middle. How can we put 3 carbons in a row between these? What do you think?
Have you considered a 3-membered ring?
What?
A 3-membered ring.
Never thought of that.
I mean, it would make sense. We have 4 hydrogens. They're all kind of around each other,
That's it.
multiplating.
That's it. Let's
They're
go
the
save the
same.
patient. We found the cure. How's the patient doing?
It's critical. Give him the meds.
Looks like he's gonna be okay.
What about my product? I'm getting my product back.
I'm sorry, the product had to be neutralized. It's not recoverable.
Looks like our job's done here, doctor.